Hello and welcome to another Valeo technical training. Today we'll be covering the advanced technologies of LED lighting designed by Valeo. Over the past 100 years, lighting has been primarily dominated by halogen technology, with little advancements up until the tech boom of the 21st century, where in the past 20 years we have seen continuous development of new innovations and the introduction of LED technology. A bit of field work back in 2015 revealed that the #1 concern for drivers on the road is visibility. This makes things like wiper blades and external lighting some of the most critical parts in a vehicle to ensure they are meeting or exceeding the expectations of the driver. Some key points that were utilized in the development of these Valeo LED technologies are that 60% of accidents that occur at night could be avoided if both cars were equipped with a high-range front lighting system. Projectors with glare-free beam adaptive functions can provide over a full second of additional time to react, and LED taillights can warn the vehicle behind you sooner, giving them more time to brake, potentially saving almost 20 feet of stopping distance at 65 miles per hour. So as with all other automotive trends, the transition to LED was the natural progression once we discovered the benefits of improved reliability, energy savings, instantaneous power, resistance to extreme situations, and lower environmental impact. LED technology is now the standard for all new vehicle production and will only continue to advance from here on out. When compared to halogen lighting, LEDs allow for reduced energy consumption and more compact and unique designs due to the enhanced control of the beam projection with cleaner cutoff lines and output modulation. And now that LED tech is more prevalent, it has become a cost-effective solution as well. Valeo's Bi-LED module was designed to replace traditional xenon applications with a unique solution that allows for low and high beam projections to be integrated into the same module. By doing this with no mechanical movement, it allows for the unique lighting design such as the Mini Cooper to adapt this technology and is compatible with either fixed or dynamic curve lighting for higher-end applications. One of the more impressive innovations Valeo brought to the auto industry is the adaptive functioning system. Essentially, the light adapts to various situations based on sensor input and surrounding conditions. Dynamic curve light provides light up to a 15-degree angle to allow for enhanced visibility when turning. Fixed beam light is the standard driving light similar to existing designs, with further projection of the passenger side light and a wider angle short projection of the driver's side light. Reacting to vehicle speed, the adaptive system provides wide short-range projection at slower speeds in residential areas and full-distance narrow projection at higher speeds on the highway. Between these two speeds, the lights project slightly further than the fixed beam light while still limiting projection of the driver's side headlight to avoid blinding oncoming traffic. The AFS also adapts to traffic with a maneuver light by limiting the projection and widening the light angle when traversing other vehicles or objects. All of this happens without any driver input, allowing you to focus on the road and your surroundings. The Valeo adaptive road lights and glare-free beam use camera and sensor inputs to modify the distribution of light according to the positions of nearby traffic. This works for oncoming traffic as well as when approaching vehicles in your lane. The lighting system will continue to adapt as the vehicle positions change to limit the potential of blinding others. One way to accomplish this is with our dynamic beam designs that either provide a multi-beam with 5 light modes to address various conditions, or sail beams that oscillate based on camera and sensor inputs, while the stationary beam provides the general light projection. This allows for situation-specific outputs with mechanical functionality. Valeo's newest innovation is the Matrix LED beam. This technology provides more precise output and modification of the light projection with the ability of LED dimming or selective shutdown. As an example, in the Audi A3, the headlight assembly contains 3 optical submodules and 5 LEDs per module, and this allows for 15 individual LED outputs to be customized based on the inputs from the vehicle surroundings. If a vehicle with the Matrix LED were to come in with certain segments out or LEDs not powering up, it will most likely be an issue of the module or input sensors rather than the LEDs themselves, so be sure to inspect these components as well. As we can see in the diagram on the right, the ability of the Matrix LED to cut light from specific segments is extremely precise and best for enhancing visibility while focusing on the safety of others at the same time. A vehicle equipped with Bi-LED assemblies with Matrix tech can have up to 30 LED outputs to modify. These segments represent various angles of projection, allowing for up to 30 output cuts across a 48-degree plane. Here we see the precise nature of the shutoff feature of the matrix LED with the vehicle in front at 50 meters. In this graphic, segment 1 is completely cut, eliminating all output from the 0 to 1 degree range, and 2 of the 3 segment 2 LEDs are shut off to expand this range just a bit further. As you would approach the oncoming vehicle, this would adapt within fractions of a second to accommodate to whatever position change the vehicle has made. This extreme level of control will cement the use of LED technology long into the future. As you can see, LED progression has already made significant leaps, and with the ability to now include thousands or even up to 1 million pixels, the ability to provide the most clear lighting and visibility to the driver comes no longer at the cost of the visibility to those around you. We expect over the next 5 to 10 years, with the mass adoption of this technology, we will see nighttime and inclement weather accidents be reduced significantly. You can already see this glare-free technology on common applications such as the Volvo XC90 and S90, the new Volkswagen Passat, the Ford Edge, and the new Audi A3. This adaptive technology was not only designed for front lighting. Valeo has also designed adaptive LED technology to assist with the visibility for following drivers and to provide them with more time to notice to begin braking. Not only do LEDs reduce the braking distance of the following vehicle, but they also provide a brighter output for enhanced visibility in all weather conditions. Some newer Valeo designs even provide adaptive intensity for day and nighttime operation. The comprehensive changeover to LED lighting solution also frees up charging system capacities for things like ADAS or infotainment. This increased need for power within vehicles can be offset somewhat by these kinds of advancements, but ultimately higher overall voltages like the 48-volt system will eventually be required to power the necessary equipment in the future. You can learn more about this in our 48-volt training module on our website. Training is crucial to the increasingly technology-rich sector of the automotive maintenance. To overcome the limitation of shop-sponsored training, Valeo has made online training modules available via valeoservice.us. You can also call us on our hotline if you have any questions regarding Valeo technologies or Valeo products that you may have purchased. If you'd like to learn more about Valeo technologies or products, check one of our other trainings out at valeoservice.us.